Well, greetings, everybody. I see lots of people brought their plates. Awesome. Thank you very much. If you didn't and you happen to forget, we have some paper plates and wooden spoons you're welcome to use. And those can go right in the compost bags. Next week, very exciting, we have a field trip. We're going to the Lighting Center. So if you want to join, I'll send around the notice next week along with a Google spreadsheet. You can sign up and we'll make sure we have enough vehicles to transport everyone. So there'll be a Lighting Center tour Nicole will give, and then she'll also present on the Million Lamp Challenge, and we'll have lunch over there. So hope you can join us for the field trip and support the Lighting Center kind of incorporation into this Energy Bites as well. So first up, we have Amanda from the Water Center. It is on. So yeah, if you can clip it on, hopefully the volume got changed from last week. And if you want, you can hold it if it doesn't clip to your shirt. Yeah?
That works.
So we'll go to 12:30.
Okay, cool. Sounds good. All right, so I'm Amanda Rupiper. I'm a grad student over at the Center for Water Energy Efficiency. And as my slide says, I'm going to be talking to you about on-site non-potable water systems. So my talk is a little bit disjointed. I'm going to start by just defining some terms because I know a lot of us aren't working in the water sector, so just making sure we're on the same page. And then I'm going to talk to you about why saving water saves energy. And then some of the barriers these types of systems are facing, specifically here in California. And then I'm going to end with just a couple slides on a project that we've been preparing for the past year. But we're just getting installed actually next week. So we're going to be kicking off this new project with Jackson Family Winery, installing an on-site non-potable water system. So I'm going to leave you with that. So first I'm going to define some terms for alternate water sources. So an alternate water source is any source that's not a traditional source, traditional being groundwater and surface water. Right now, drinking water only can come from traditional sources, groundwater and surface water. And so these alternate sources are used for non-potable applications. And that would be your foundation drainage, stormwater, rainwater, black water, and gray water. Most water reuse systems that are in buildings are gray water because they don't have as much requirements. So gray water is any wastewater that does not have fecal contamination, so not from your toilet. And here in California, it also includes your kitchen sink. So kitchen sink is considered black water in California because of the high nutrient load. So black water would be toilet water, kitchen sink water, everything else, gray water. Rainwater is defined as water that's collected above grade from a man-made surface, whereas stormwater is water that's collected from runoff. That's defined differently by states, but that's how California defines it. And then foundation drainage is just shallow groundwater that seeps into your foundation. So these water sources can all be used in an on-site system. So an on-site non-potable water system, which you're going to hear a lot today, is a system that uses a local alternate water source, so one of those 5 I listed, for a non-potable application in close proximity to where it was collected. So you might think in your home, if you're reusing your shower water for irrigation on site, that would be considered a very small scale on-site non-potable water system. This contrasts with typical water recycling that we think of in those big purple pipes being sent out to golf courses, which is a centralized system, so that takes black water, sends it to a centralized facility, and then sends it back out again. So this is keeping it all in one location. And you can imagine there are benefits by doing this. So if just on a residential scale, they only recycled their gray water, you could reduce your potable water demand by 30% on a residential scale. And on a commercial scale, you can reduce it by up to 75%. And that's largely because a lot of commercial water is used for industrial processing and manufacturing that can be recycled, and also for cooling. So there's a huge potential, both at residential and commercial scale, for saving water. And when you save water, you save energy because a lot of water goes into producing potable water. Whether you get it from groundwater, pumping it from wells, which is a lot of energy, especially as our water table is declining, we have to pump it further. Or whether you're having to treat surface water, that uses energy. Then once you treat it or you pump it, you have to then send it out to your system, which requires booster pumps. That uses a lot of energy. And then when you use it once on site, you have to send it to be treated for wastewater. That uses a lot of energy. Then they can either send it back and start over again, or they send it out, which also uses energy, as recycled water. When you're reducing your energy or your water use on site, you reduce every single step. If you reduce by 75%, you're doing this 75% less. So there's a lot of energy savings. Now, of course, all of these steps have different amounts of energy associated with them, depending on where you are, where you're getting your water from. It's variable, so it's not an exact energy, where you are, you're going to save more energy versus others. But overall, you're saving energy when you save water. So that's how it relates for this talk. So these systems are facing barriers, and a lot of it is because of the way they're regulated. So prior to 2010, there were no regulations in California for on-site reuse, gray water specifically. Currently in the United States, about half the states allow gray water and about half don't. So the ones in blue here have regulations for gray water reuse. The ones in white either have no regulations or they simply do not allow gray water reuse. So this is a relatively new thing, even though it doesn't seem like a new thing, but 2010 was the first time it was allowed in California. So with the updating of the plumbing code and this suddenly being allowed, they decided to send a survey out in 2015 to see what's happening with this. And so they surveyed, this is mostly in Southern California, they surveyed all the environmental health directors and they found that 95% of these health directors believe on-site non-potable reuse is important for the future of California. But of those same directors, 82% were unsure of the regulations and their role in regulating it. So you can imagine the problem right now. If the regulators don't know what the regulations are or how to regulate it, it's going to be difficult to get these systems installed and get them up and running appropriately. And a lot of that has to do with because these regulations are new, but also because of how gray water or water reuse is regulated. So this is a very busy slide. I apologize for that. But what I want you to take away from this is there are 5 documents right now that regulate non-potable water, so non-drinking water. That's Title 17, Title 22, and 3 chapters of the Plumbing Code. Title 17 and Title 22 also regulate drinking water, and they've been around for decades. They've been around for a very long time. They're very well established. People understand them. They also regulate black water, so that would be your centralized treated water. So when you think of recycled water and the purple pipes and golf courses, you're thinking of recycled water from black water. People understand that because it's been around for decades. This gray water, or non-black water, is only regulated through the plumbing code, which is new. So it's not as clear what's going on. And the cool thing about Title 22 is for water quality, it actually lays out all the different water quality standards you could meet. And then if you meet this level of water quality, you can do these number of uses. If you meet this water quality, you can do these end uses. For gray water, or non-black water sources, it leaves it up to the local authority to decide. So you go to your local authority and be like, hey, I want to do this. What kind of water quality do I have to meet? What end uses do I have to do? Now the problem is, each local authority might not know their responsibility in deciding this. And a local authority, that's a lot of burden to put on them to come up with their own standards, right? They have to base it in some sort of science, some sort of fact. They're not going to just make it out of nowhere. And so what's happening is a lot of them are just defaulting to Title 22 because that's established, right? So leaving it up to the local authority has caused some issues. So I'm going to just list right now a whole bunch of barriers, and I'm not going to go through them all. But what we're finding is these systems aren't taking off because there's a number of barriers preventing them from happening. One being lack of coordination between local agencies. There's a lot of agencies that regulate this, and they don't necessarily work together. There's confusion about the requirements. Wastewater utilities are like, you're taking our water, you're taking our business. We don't want to support that. Absence of monitoring reporting qualities. There's a whole bunch of them, but I'm only going to talk to you about 3, just for sake of time. So gray water, before it can become recycled water, has to get over all of these challenges in order to happen. And the 3 I want to talk to you about are the authority having jurisdiction from code, the non-standard criteria that exists in the state, as well as the inappropriate requirements that are put on gray water. So let's start with authority having jurisdiction. So in the plumbing code, in chapter 15, it mentions this authority having jurisdiction getting to decide how the water is used and what water quality you have to meet. And when I first read that, I didn't know who the local authority was. It doesn't tell you. So I went to the definition just to see, and I apologize, I'm going to read it. The authority having jurisdiction shall be the federal, state, local, or other regional department, or an individual such as a plumbing official, mechanical official, labor department official, health department official, building official, or other having statutory authority. So it could be a lot of people, right? And what I'm finding is a lot of different agencies, or a lot of different areas, have different regulatory authorities. So if you're in this area, you might have just your building department. If you're in this area, it might be 4 different people that are regulating you, and they might not be working together. So there's a problem there, right? In San Francisco, which is kind of the champion of this, they're the furthest along on this, they actually have 3 regulatory authorities. They have the SFPUC, the Department of Public Health, and the Department of Building Inspection. And they work together, so each one of them has certain roles in regulating it. But in other agencies, they might have 4, or they might only have 1, or they might have 2, but they don't coordinate, so they might be doing the exact same things, right? LA is also doing it. These are the only 2 areas that have very clear. So these are the requirements that they put out because they get to decide. And they have, the building department gives you the permit, but then you're supposed to get a check by the health department. And what's happening in LA, I was talking with the guy who regulates this, he's saying that over half of the systems get their permit from the building inspection, and that's it, they're done, they go. Because the building inspection doesn't ever tell them, oh, you need to get checked by the health department. So half of these systems are not in compliance. They're doing whatever they want to do. Just because the agencies aren't coordinating. So that can cause a problem for these systems that are, who knows what they're being used for and the risk that could be associated. So that's barrier one. The second barrier is this non-uniform criteria. So if each local authority can come up with their own water quality, and maybe there's multiple authorities and they each have different water quality standards, there's going to be conflict. Some are going to be very protective, some are going to be less protective, and that doesn't really make sense if the goal is protecting public health, but not overly protecting it, I guess. And so what's being done about this, there's actually some work being done about this. There's a bill out right now, Senate Bill 966. It just got put forth in January. It didn't pass last year, so we're hoping it passes this year. And if this bill goes through, it will standardize the water quality criteria, as well as the monitoring and reporting requirements. So that way people who are installing the systems knows what's expected of them, right? If you're an installer and if each city requires a different thing, it's going to be really hard to design your system. So if it's the same, it'll make it easier for the installers as well. The reason it didn't go through last year, I've heard rumors, is that the wastewater utility was opposed to it, and so shot it down. So it just got passed for appropriations 2 weeks ago. So we'll see if it passes this year, because that would be a big barrier, or a big hurdle that we've overcome. Okay, so last barrier is this inappropriate requirements. I mentioned how, because Title 22 has been around for so long, it's really easy to default to that because people understand it. And that's happening, but black water and rainwater have different levels of risk, so it really doesn't make sense to do it together. And Title 22 requires that you test your water every single day. Individual residences or businesses are not going to test their water every single day, so it immediately puts them out like, no, it's too much, I'm not going to do it. So if the requirements don't fit the purpose of the water, it's going to prevent people from doing it. Right now, if a local authority doesn't decide on a water quality criteria for you, then you have to meet this NSF standard, which was put forth by the National Sanitation Foundation, not Science Foundation. And it's just this general, generic standard that they put. It's not based on risk. So if you're spraying recycled water in a park, it's going to be more risk than if you're spraying at night in a graveyard, for example, right? There's different levels of risk, so you should have different levels of water quality. It doesn't note that. So it's not basing it on the use. It's just a general blanket standard they just decided to apply, which could be overprotective or underprotective, depending on the system. And then lastly, there's just absolutely no monitoring and reporting requirements in existence right now. So when you install your system, you get your cross-connection test by the plumbing department, and then you're never inspected again, which for a single-family home might be fine. But if you're an apartment building serving hundreds of people, and your system is never inspected 40 years from now, who's to say it's not causing problems? So you need to have some sort of a plan for that, at least. So there's a whole bunch of barriers, and how do we address them? I mean, one way is with legislation, which is what Senate Bill 966 is trying to do. But maybe part of it is having a mandate for reuse, right? We ask people to restrict our water, but maybe we could ask people to reuse water, especially at big buildings where there's a big potential. So at a big new construction of an apartment building, maybe they just install a reuse system. Or maybe new construction of residential has, the stub outs for plumbing, so they can just hook up a system really easily. It's hard to retrofit, but if we could mandate it for new use, that could be one way to address the barrier. Providing resources and training. We have all this knowledge out there, but the local authorities aren't getting it, obviously, based on that survey. 82% don't know what they're doing. So maybe we need workshops to get the trainings out there. This is what water quality should be hitting. More research on the benefits and risk, because right now there's just not a demand, and part of it is because we don't know how to do it. But part of it is these systems are expensive right now. If you were to install a gray water system on your home, it's not necessarily cost effective for you to do so. So there's just no driver there. Maybe a rebate or maybe some sort of other incentive to do it, or more research on the benefits could be helpful. And then also getting those regulators to coordinate. Like in San Francisco, they have 3 regulators coordinating together and taking different roles. We need to get all the regulators on the same page so they're regulating appropriately. So that's the barrier side. So I'm going to actually leave you with just my last couple slides on this project we're doing in Jackson Family. So this is kind of the application side of it. So most of this we imagine are in our homes, but the real benefit is in the commercial sector. If you remember that slide, 75% of your potable water could be reduced if a commercial facility could install this. And so we chose an industry. We chose the wine industry largely because there's just a lot of wine in California. California is the 4th largest producer of wine in the world, and 90% of the wine consumed in the United States comes from California. So there's a lot of potential. They are the 2nd largest energy user in the food industry, using 400 gigawatt hours per year. So they use a lot of energy. And the production of wine itself takes 6 barrels of water to produce 1 barrel of wine. So if we could just tap in just to the production side, we could be saving 4 billion gallons of water annually just for wine. So if we can tap into this industry, then we can also tap into a lot of other commercial industries and save water. So the project that's actually getting installed next week, we're very excited about, is family. And we're going to be tracking them on the permitting side, their barriers, but we're also going to be installing the system itself. So what we're installing is a reverse osmosis membrane. And we're going to be taking all of their barrel wash water and their tank wash and their cooling tower water and recycling it through the membrane and reusing it for the same purpose. So it'll be a direct loop recycle on site. Currently what's happening is they're sending it to wastewater ponds. They have 5 wastewater ponds, which they aerate, which is very energy intensive. 2 of those wastewater ponds create water for irrigation, so they send that water off for their fields. And then 3 of those are sent to the Sonoma County Water Agency as wastewater, which has to then further treat it. So the hope is by doing this, by recycling their water, they're actually going to eliminate 3 of their ponds, so 3 of the aerators as well, and they're going to gain a whole bunch of land space, which they're excited about. And they will no longer be sending water to Sonoma County. They'll just be using it on site, which will be pretty exciting. Now, most often reverse osmosis is not used for wastewater treatment, and it's because reverse osmosis is not very efficient. It takes a lot of energy, you have to operate at really high pressures, and you usually waste about 40% of your water and you only get 60% back. So it's not used mostly for waste treatment. But what we're going to be using is this method, this Vibratory Shear enhanced process, which is a product of New Logic. It's been used in the oil and gas and the dairy industry, but not very often in the water. Actually, this is kind of their first breaking into their water industry. And it's different because it's a reverse osmosis membrane, but instead of just a membrane, the membrane vibrates. And so when it vibrates, it causes this lift at the surface, this shear. So typical reverse osmosis, you get the cross flow across the membrane, and then particles foul it, land on the membrane, preventing it from getting through. And then you have to increase the pressure to get more and more through. So you're increasing the pressure to the point where eventually so much pressure you have to backwash and you have to waste a whole bunch of water. Because it's vibrating, it doesn't foul as fast, it just clears the contaminants out. So New Logic has proposed or predicted that it will get about 90% throughput as opposed to 60. So it's a huge increase in their throughput. So we're expecting to get 90% of our water back and only waste 10%. Not only that, but that 10% is also more concentrated, so it takes up less volume. So there's a benefit there. And then we're not having to increase pressure, so there's an energy benefit as well. So this is actually what the technology looks like. The membranes are loaded into this tower. So it's layers and layers of the membranes. They vibrate. We run all the wastewater through it. And what we're predicting is we're going to get about 90% recovery of their fresh water, which for Jackson Family is about 1.4 million gallons per year, and about a 60% reduction in their energy use, which for them is about 42,000 kilowatt hours per year, which is about $5,000 for them annually, and then about 31,000 pounds of carbon dioxide equivalent per year. So huge benefits. So we'll be tracking this over the next 12 months, seeing if they're actually getting this and that they're meeting their water quality standards, as well as tracking the permitting process to see what barriers they're hitting. So that's it. I don't have much more than that, but I just want to leave you with, this is the takeaway, I guess, that on-site non-potable systems can reduce overall potable water demand and energy demand. But in spite of this, they're facing many barriers that's preventing them from gaining traction and becoming widespread. And so we're kind of researching these barriers and seeing what's happening. So that's all I have. So if you have any questions, I'll take them now. So it's more concentrated, yes. So the hope is that we're going to get it so thick it'll be more like a sludge, so that you'll treat it more like a solid than a liquid. So it's just a different treatment. But you're right, you do have to consider that going in. But it's going to be sent off to another wastewater treatment facility, which will dilute it out with other water, so it won't be as concentrated once it's actually treated.
Have they considered anaerobic digestion or supercritical water?
I don't know if they did. This is just what they're doing because they don't have a lot of space. So this unit itself takes up about maybe 2 of these tables. So it's very small. So they don't have a lot of land space. So this was this fit for them. So I don't know if they considered anything else. Yeah. Yeah. Yeah, this was from the proposal, which was several years ago, so I'm not actually sure the current number if we were to estimate it now, but you're right. They could be variable cost based on time of use. Yeah.
I guess to follow on to that, the question might be,
That's what we're not sure about because we don't know how long this treatment, because I haven't installed it yet, so we don't know how often we'll have to run it, how often it's going to foul. So depending on their operations, I mean, they only operate when they're there, so they're generating wastewater during the day. So it's possible they could operate at night and then generate their water for the next day. We'll find out once we install it. We'll have better knowledge. Yeah. It's expensive. At this point, I don't have an exact number because we have not officially installed it yet, but it's not cheap. So this is just getting started, and a lot of the reason that it's not cheap is because it's not a package unit. So you have to have all this design work. You can't just take it and then put it in place. So that's one of the barriers is the cost, and there's a lot of other technologies. This is just one technology.
Hundreds of thousands or millions? Or?
I don't have an exact number. Hundreds of thousands is correct, but I'm not sure the exact number. The water. Their water was 1.4 million gallons annually. So they actually pump from a groundwater well on site. So they will no longer be pumping, yeah. Well, and also they'll be saving their aquifer, so they could potentially have that water for growth. They could expand growth, yeah.
what's the value of the land?
I have no idea, but they were very excited about this new land they'd have when they got rid of their wastewater treatment facility, their ponds. Yeah.
The value of the land plus there's the real estate of it being usable to extend. They've expressed extreme happiness.
So this has been done at one other winery using a membrane bioreactor, which takes up a little more space. So there's lots of different ways this can be treated. They chose this one for a lot of reasons, but mostly because of its small footprint, because it's very small and compact. Yeah.
Are they using any incentives or
We are, so it's a part of a CEC grant, where CEC grant covers most of it, and they're putting in some percentage. And I don't know the exact percentages of that, yeah.
what percentage of water retrofits are actually?
That is really hard to find, because if they're not permitted, they're not tracked. And actually right now there's no tracking for gray water. So there are two systems that don't require a permit. So your laundry to landscape, taking your laundry water, you can do that right now. You don't need a permit. Also external capture of rainwater for irrigation, that doesn't require a permit. So it would be more like if you're capturing your bath water or you're reusing indoors, that would require a permit. So all those small ones are not permitted and not tracked. So I have no idea. Yeah. Thank you.
Right. Next, we're fortunate to have Maria here from the Carbon Neutrality Initiative. Kind of give us an overview of those efforts. So we can try to, yeah, you can also just hold it. Just kind of hold it this way. So whatever works. But yeah, because like hair, I've noticed the hair makes it sound weird and it's choppy.
This is all right. Okay. Good morning or good afternoon, I guess. My name is Maria Wong, and this is Kristen Hope. We're both CNI fellows. We work for the University Office of the President under the Carbon Neutrality Initiative Fellowship. And we work at UC Davis since we're UC Davis students. And our main job in this role is to talk about what the Carbon Neutrality Initiative is and to educate and bring awareness to the general student population about sustainability issues and what the position of the university officially is about these issues and what it's trying to achieve. And so we're going to start talking about a brief overview of what the Carbon Neutrality Initiative is, part of its history, part of its present, and about its future as well. And then we're going to end talking about our outreach and engagement projects for this year and what we have accomplished thus far. So in the last 50 years, the University of California has spearheaded climate research, and we have several very well-known scientists in this area. Most famously, Professor Charles David Keeling and Professors Shear, Roland, and Mario Molina. In the 1950s, Professor Keeling did seminal work in measuring the CO2 concentrations in the atmosphere, something that wasn't done accurately until he came along. And for that, he received a Nobel Prize. And similarly, Professors Roland and Molina, well, Molina was a postdoc at the time, and they did important work relating to the ozone layer in the atmosphere. It's actually, their work predated the actual measurements of the ozone layer deficiency in the North Pole, but they had the insight to point to aerosols as affecting the concentrations of the ozone layer because of a chemical reaction with the chlorofluorocarbons, CFCs for short. And so because of this insightful research, the university as a whole couldn't stay behind. And so the university started to incorporate these climate initiatives into their policies, albeit a little bit later. So starting in 2006, the University of California started to incorporate climate policies into its overall goals. And the first policy that came along was to reduce carbon emissions by 2020 to what they were in 1990. We reached this goal actually in 2014 by a series of actions that Kristen's going to explain later. And in 2007, they signed into the American College and University President's Climate Commitment as a charter. So we have to abide ourselves to this climate commitment that was signed nationwide. And in 2011, they formed a UC-wide committee that wrote a report about what the next steps would be for the future of the UC in terms of climate change. But the most important for our presentation and for all of us as part of the UC system is the UC Carbon Neutrality Initiative created by President Napolitano. Before this came along, we had smaller goals, but she decided to make the UC carbon neutral by 2025, which is a very ambitious goal in terms of what the worldwide efforts are.
Yeah. So I'm Kristen Hoag, and I am the other Carbon Neutrality Initiative Student Engagement Fellow out of the UC Office of the President. I'm going to talk to you about the Carbon Neutrality Initiative goals that are currently being worked on. Obviously, the first one is to have the entire University of California system, and that's all 10 campuses, all 5 medical centers, and all of the laboratories, carbon neutral by 2025, and that means emitting 0 net greenhouse gases from its buildings and vehicle fleet. They're going to be doing this in 2 ways. The first way is to eliminate direct emissions from operations, and so that's fuel combustion in buildings, vehicles, emissions, and agricultural emissions. So there are many new building projects that you see on campuses UC-wide. They're all being LEED certified. Most are LEED certified gold. It's really difficult to get to platinum. I mean, if you work in a laboratory, you probably understand that it's difficult to get to a LEED platinum certification. LEED Gold seems to be the standard. Where we're seeing a lot of this new building growth is actually at UC Merced. They're doubling the size of their built campus by 2020. and everything that they're putting in that's brand new is at least LEED Gold certified. So you see these new buildings coming online in UC that are going to be meeting these new requirements. The second way that we're going to be meeting these goals is by reducing the indirect emissions from the generation of purchased electricity. And I'm going to talk to you a little bit about how we're going to do that. So some of the ways that we're going to be achieving carbon neutrality is, first of all, with the on-campus demand on all of our UC campuses. Investing in energy efficiency and renewable generation to reduce the campus load. And I'm going to talk in the next slide about some of the projects that are actually doing that. Biomethane development. And so I'm an English major, not really versed in some of these terms, but I'll do my best, and I can also send out information to you after the presentation with some more specific, scientific numbers and data and facts, if that's what you'd like. So the biomethane development transition from natural gas to biomethane to fuel the UC electrical plant facilities. So we're actually changing the supply of energy to the UC campuses, and in some cases, this is easy for us to do because we have aging buildings that need to be rebuilt, that need to be replaced. In other cases, we have buildings that are really early on in their life cycle that are energy intensive buildings. And there's some buildings like this that were recently built at UCLA that we're discussing right now, and they're relatively young buildings in their life cycle. So there's this internal, conversation that's happening within UC as to, what are we going to do with these buildings that are early in their life cycle but are utilizing more energy and are not energy efficient. So, those are some solutions that we're working on just right now at this time. We're also working on our off-campus electrical supply. We're entering the wholesale electrical market to manage energy supply and, create this flexible portfolio of electricity that we can do. And so I'm going to also talk to you about what we're doing right here on campus. So the first thing that we have on campus is we have an anaerobic digester. And the digester, it blends organic waste. So, all of the food that's the waste food on campus is taken to this biodigester, and it's actually located right down there past the primate center. So past the primate center and on the right, there's a facility, it looks like, water domes that are white water domes, and that's the biodigester. And it generates approximately 5.6 million kilowatt hours of electricity when operating at full capacity. About the biodigester, it was actually originally owned and operated by Clean World, and it was installed in 2014. UC Davis purchased this biodigester in 2017, and right now, it's actually offline. It had some technical difficulties, so it's being retrofitted, so it's not functioning at this very moment. But when it is functioning, it converts 50 tons of organic waste to 12,000 kilowatt hours of renewable technology in the form of biogas and liquid and solid products. The biodigester technology was developed by Professor Ruhong Zhang, who's still here on campus, developed about a decade ago. And we have an expert in the biodigester, within the Carbon Neutrality Initiative. And his name is Tyler Barzey, and he's a PhD candidate in biological and agricultural engineering. He's also one of our CNI fellows, and his research is actually on utilizing the biogas and the waste products that come out of the biodigester process. So that's been really neat. The next campus highlight I wanted to talk to you about is the solar farm. UC Davis has this huge 62-acre solar farm, and it's on that side of Highway 80. And it's the largest solar installation on a university campus in the United States. SunPower is the company that owns and operates the solar farm. And looking historically, I did some research before this presentation, wondering, how come we did this privately. The University of California did this huge 62-acre solar installation without, doing it in-house. And, what I was able to find historically was they did go with a private company because of tax reasons, that there were tax breaks that were available to private companies that weren't available to the University of California system. So there was definitely a cost savings there by having SunPower, which is the company, install. They actually own and installed and operate this solar farm facility. And, the land is UC Davis land. It's 62 acres. It was opened in 2015. It generates 14% of our campus electricity. It's a 16.3 megawatt facility. And what's really neat about the solar farm, and I've been over there, I've taken a tour, and I really think it's cool, is they have these tiny little robots. And the robots are responsible for doing all of the cleaning on the top of the solar panel. And it's this really new technology that uses 75% less water than the traditional cleaning technology. And so this is done at night, and it takes 2 people to go through 11,000 panels and set up these robots that go across and clean and keep those panels clean, because as you know, for energy efficiency, the panels have to be very clean to capture as much sunlight and convert that into energy. Let's see what else I can tell you about it. It reduces our campus carbon footprint by 9%, or 14,000 metric tons. So it's one of these installations that we have that's moving us more towards carbon neutrality. As far as the other UC campuses, each UC campus is at a different place. UC Irvine is already carbon neutral. I believe 4 or 5 campuses are already at 1990 levels, and UC Davis is one of them. And as far as reaching this goal, we are on track. It's going to be close. But we are on track to meet this goal in 2025 based upon, installation projects that we have in the pipeline, building projects that we have in the pipeline, and this electrical energy offsetting that we have going on. So next, I'm going to talk about specifically, what we do as Carbon Neutrality Initiative Student Engagement Fellows is they bring us on, the UC Office of the President brings us on within the Carbon Neutrality Initiative to conduct student projects. And what our projects are for is to, and I have this written down right here, so our projects are about education, and the entire UC community is involved in this carbon neutrality effort. And, we're responsible for educating the campus about this initiative, engaging more students, engaging more groups such as yourself in this initiative, and sort of being ambassadors for the initiative, and that's part of the responsibilities of our fellowship. A little bit more about the way the Carbon Neutrality Initiative is structured. So it's like this 3-pronged structure. There's the student engagement portion that you see here with Maria and I. There's also something called the Global Climate Leadership Council. And the Global Climate Leadership Council is, it consists of, let me pull that up. It consists of scientists, administrators, students, and experts, both inside and outside the University of California system, that advise UC on climate policy and projects within the UC system. And this Global Climate Leadership Council meets several times a year to discuss initiatives and discuss policies and actually advise the UC Office of the President on the direction that the University of California takes. As student engagement fellows, we are supported in attending these meetings, in giving student input into the policy and projects of these meetings. And I attended the last meeting that was at UC Merced, and it's a great experience. And they're doing a lot of, we're gearing up for the Cool Campus Challenge, which is going to be happening next year, which is UC-wide, which is going to be this effort to educate the student body on behaviors and habits of sustainability. And we, other pilot projects reducing, air travel of faculty and administrators, or offsetting that air travel, because University of California has a huge footprint with our air travel. So those are just some of the projects that they're undertaking at the Global Climate Leadership Council level. And So now what I'm going to do is I am going to really bring it down to like this campus. So bring it out of the overall UCOP level and just let you know some of the student engagement projects that we have going on this campus. And I'm going to hand it over to Maria so that she can tell you about her projects.
Okay. So whenever somebody does outreach and engagement, there's something that they want you to know. What is our goal as Sustainability Engagement Fellows? First of all, we want to educate people. When I was talking first about UC climate research, we talked about the science, but we didn't talk about the social science or the economics of it. And sustainability issues have to be solved from 3 standpoints: science, economics, and social issues. And if we don't address the 3 of them, then we're not doing our job. However, we mostly think about sustainability from the science point of view. We think about climate change, we think about pollutants in the air and how they affect our lives. And we talk about the changes in temperature, the rising levels of the sea. But have we addressed the social issues that are accompanying these changes in the climate? And another way that students face sustainability is culturally. On campus, there's different students groups that address sustainability, but they usually have a certain visage that comes along with them, and a term that's usually used is crunchy. So how can we make sustainability more accessible to the overall population? And a way to do that is to educate people that sustainable behaviors do not have to come attached to a knowledge or a deep knowledge of science or changes in your own culture or the way that you relate to your everyday life. Another goal that we want to achieve is behavioral changes. We don't want people to change their whole view of the world before they start making behavioral changes. Can we make people just recycle without having to compromise other parts of their experience of their lives? Can we make it a simple change that they can adopt immediately? And third, our main goal as CNI Fellows is in our name. We want to let people know, and students specifically know, that their university is committed to carbon neutrality. So, I tried to organize 3 different events. The first one is a way to visualize what a metric ton of CO2 is. A lot of scientific journals, scientific communication media talk about greenhouse gas emissions. They talk about several millions of metric tons of CO2 being released into the atmosphere and changing our climate. But how much is a ton of CO2? Can I have a raise of hands? How large is a ton of CO2? According to the noble gas law. It's pretty large. It's the size of a 2-story building. And we're talking about these metrics, but we don't really have a way to visualize it. Right? So our first goal was to help students visualize a metric ton of CO2. And so we found different ways to do that, but we ended up collaborating with a university professor in the art department. And she specializes in large-size art installations, and we're working on developing a clear cube made out of plastic tubes that will encompass the whole volume of a metric ton of CO2 and will be placed at the quad for a whole day. And will engage students to think critically about what it means to emit a ton of CO2 and how a ton of CO2 is related to their behaviors. Like an average car emits about 4.7 tons of CO2 per year. The second project that I'm working on is, or that I worked on, is a Multidisciplinary Sustainability Research Symposium. As I was saying, a lot of sustainability on campus is housed in the departments that they work in. So this is the Transportation Institute, or the Institute of Transportation. There's also the Plant Sciences Department, and many of these departments work on sustainability projects, but they don't necessarily speak to each other. Kristen, she's in the English department, and she works in sustainability research. I'm in the chemistry department, and I work in sustainability research. How can we make these different students in different areas of research talk to each other and be exposed to research in economics or in social science that also pertains to sustainability. Because we're talking about a problem that has three areas: social issues, economic issues, and scientific issues. And I planned this event. It wasn't as successful as it could have been, and we've learned from this event, and we've learned new ways to engage students. And we've also seen, one of the main issues that we had with organizing this research symposium was that when we asked students who applied to the undergraduate research conference on campus, it wasn't clear to them what sustainability meant. We asked them, is your research related to sustainability? And we had a widespread of students who clicked that they were related to sustainability, whereas according to the definition that we have of sustainability, they did not, that did not coincide. So it demonstrates that there's a lot of work to do educating our students on what it actually means to be sustainable and what it doesn't mean to be sustainable. And finally, we developed tree signage that is related to behavioral changes. How can we relate the statistics that we talk about to simple changes in your behavior? If 4.7 tons of CO2 is emitted by your car every year, how can you change that? Can you bike more? Can you walk more? Take the bus? And then another important behavioral change that we want to address is to behaviors that relate to metrics that are directly related to CO2 emissions. A lot of times it's hard to make the relationship between the water waste and the CO2 cost that it entails. Most of the water in California is groundwater and has to be pumped and has to be transported from, for example, most of the water in Southern California comes from Northern California. How much water somebody spends washing their car in Southern California, it costs money to the state to transport it from North California to Southern California, and then that water that goes into the waste stream has to be treated before it goes back in. That costs energy. How can we let people know about this? So we created a tree signage project that it would have posters that describe the relationship between behaviors and the energy costs that they entail, and how to make simple changes in your life, like just take a shorter shower, for example. 5-minute showers are efficient enough so as to be socially responsible, but also allow us to control our water waste. And so those are the 3 projects that I worked on this year.
So before we get to my project, as you heard Maria say, and I said before, I'm an English major. And when I first came into this fellowship at the beginning of last year, they take all of the fellows, the incoming fellows, and we go to the California Higher Education and Sustainability Conference at UC Santa Barbara, and we have training. And, when I got to that training, I was asked time and time again, well, what does an English major care about climate change and sustainability? I mean, what are you doing here? I mean, don't you just read Emily Dickinson and Wordsworth and bust out sonnets all the time? and so there was definitely a disconnect that I noticed between, the scientific community, the science majors, the policy majors, and the humanities. And one of the breakout sessions that I sat in at CHESC actually had some research that was done by some UC Santa Barbara students where they surveyed the students about sustainability behaviors across major, identifying the students by major. And it was sad for me because what it showed is that the humanities majors, we weren't aware of behaviors of sustainability. We weren't aware of climate science. And we weren't recycling, we weren't changing our behavior, and so it was sort of depressing for me. So my project that I designed was actually, in addition to our responsibilities for being an ambassador and doing presentations such as this and attending the Global Climate Leadership Council meetings, I took on this huge, massive project, and I actually am a 5th-year undergraduate, and for the, within the associated students, like the the constitution that we have for the Associated Students of UC Davis, there's a place in there where students, undergraduates, can actually design and teach a student-led course. Like a real course, it's up there on Schedule Builder, students, sign up for it, and, they assign you a classroom and everything like that, and you do this under an advisor. So what I did is I started back in the winter, and I proposed a course that I wanted to design and teach in this quarter, in spring. And, went through all of the groundwork. I had to submit a proposal to the English department and have the department head sign off on it, and I had to find an advisor to advise me. And so I created this course, and the name of the course, it's under the 198F designation. It's ENL 198F, and it's Discourses of Climate Change and Sustainability in the Humanities. And I'll read you the description for this course. And I'm teaching this course right now, so right during this quarter, every Tuesday and Thursday, I have a class of students, and I go in there and I teach, and it's super fun. And so the reason why I called it discourses was I'm sort of riffing off a philosopher. Jürgen Habermas first identified public discourse as a domain of our social life in which such a thing as public opinion can be formed. And my student-led course revolves around the current discourses of climate change and sustainability in the environmental humanities. And we're exploring the opportunity that these discourses have in imbuing public opinion. So we're actually looking at why isn't the public listening to the scientists? And we're taking a look at what can the environmental humanities do? How can we repackage that information, that scientific information? And, we do this by looking at environmental literature, art, poetry, music, and within the genres of environmental literature, we're looking at the genre of the news, journalism, fiction, nonfiction, apocalyptic fiction. And so what we're doing, our imperative is to inform and extend our understanding of climate science, climate change mitigation, conservation, and sustainability through new interpretations of novels, poetry, films, art, and music. And through the intersections of politics and art, science and film, environmental activism and personal narrative, we contextualize the environmental social movements of our current moment. And by thinking uniquely and imaginatively about society's accelerating environmental problems, we explore the ways the sciences and humanities offer solution and develop alternative social frameworks of understanding. Finally, at the end of this course, I give my students an opportunity to, we do this project where we write a letter to the future, and I'm partnering with this nonprofit organization called DearTomorrow.org that actually is a time capsule, so they're capturing these letters to the future in this time capsule, and these letters are about, what my students know about climate change and sustainability and commitments that they want to make in the future. And then their letters at the end of this course will be encapsulated within this nonprofit project. So that's a little bit about my project, and I think that at this point in time, does anybody have any questions? We can answer any questions that you have. Right now there's 4 fellows. Lauren Jabush, who's a PhD student in agricultural engineering. Tyler Barzy, who I told you about, who works with the biodigester, and he's also a graduate student. And then Maria and myself. Lauren is actually a research fellow, and then Tyler, Maria, and I are engagement fellows. And we do get to pick our own projects. We do the research, and then we propose our own projects. And they support us with them. Mm-hmm. The deadline's actually the 21st. And, Maria or myself or Tyler, we're happy to talk with anybody who's interested in being a fellow. Next year, they have funding for 3 fellowships. And they're actually splitting the fellowships. There's going to be these student engagement fellowships, again, the engagement fellowships. But then there's a new type of fellowship that they're designing called the Climate Action Fellowship. And, it's open to graduate and undergraduate students. It is paid. It's a paid fellowship. So it's a great opportunity. I've had a wonderful year. This fellowship for me actually foregrounded my research emphasis in graduate school, and I'll be going on to my PhD next year. Okay.
Sure. To bring this back to us.
Great.
We're one of the largest.
That whole CNI initiative, trying to get people to swap out their light bulbs. And they have a fully buy program, so they're going to offer discounts to all employees to buy LED light bulbs. So that's part of this big initiative.
I got the impression that so we're here on campus land, purview. It'd be interesting to think about, the campus is thinking about faculty air travel or faculty air travel and
You just hit on a current conversation that's occurring at this moment, and that is the conversation between the leased buildings. For example, the biodigester, even though it was on UC Davis land, it wasn't owned by us for the first 3 years. We don't own the solar farm. It's just on our land. So that's a current conversation that we're having on what kind of oversight do we have on those leased buildings. I don't have any answers for you today. I can just tell you that's it. That's
I'm sort
yeah.
of living that every day.
Yeah.
So it's
Yeah.
been a frustrating, I mean, even just our Anyway,
Yeah. No.
feel free to bring that.
Yeah, no, and I will. The next Global Climate Leadership Council meeting is actually going to be in Oakland. It's on June 6th. I'll be attending that. I have a whole list of thoughts, such as yours, that I'm bringing to that meeting, and I will make sure that that's on it. CNI is all for divestment of fossil fuels within the UC system. Not only that, we take it a step further. All of the CNI fellows signed on to a beef-free UC sort of initiative at the beginning of this year. So we... Correct. Exactly, with our cows. But we did. We talked about, within CNI, we've talked about the impact of the beef industry and just how much that impacts emissions and how much just the UC system with its, utilization of beef and serving of beef, what we could do to bring emissions down and how much it would actually save us just by going to beef-free UC. So that happened at the beginning of the year. But yeah, no, we're right there with you with divestment. The fellows are.
But, I mean, specifically,
Yeah, we're pushing. I think that the student fellows that are from all 10 campuses, and we meet together and we communicate with one another, we're definitely pushing. You know, we're a little bit further ahead where we understand and we see where we need to go. And, you know, the University of California system is a bureaucratic structure and moves slower. And they do listen to the students, and, you know, we have loud voices, and we keep pushing. And we will keep pushing. Thank you.